So don't forget, your test is Tuesday, and there's some MyMath Labs that are due this week, so make sure you're working on MyMath Lab as well.
No more extensions.
All right, so let's kind of review this. Okay, so suppose you want to graph this equation. Now, what kind of equation is this? It's linear. In fact, one of the things you had to turn in today, one of the worksheets, is for you to determine whether an equation was linear or not. So that was due today. We talked about that last week sometime. But this is linear. And if you want to graph this linear equation, what might you want to do first? Look at it. Get x by itself. Okay? In this particular case, it's easier to graph it if you can get x by itself. So this is going to be on your test Tuesday. So how would you get x by itself?
Divide by 2.
Divide both sides by 2. All right, so you get something that looks like this. Now, this is what I have. Now, the left side is easy to deal with because 2x divided by 2 is just x. All right, now how do you want to rewrite the right side?
You can multiply everything by 2.
No. If you multiply everything by 2, you get that 2x again.
Oh, yeah, no.
Break it down into two fractions. So negative 3y plus 8 divided by 2 is kind of like, you got to remember something from your previous experience. Remember, if I have 8 plus 6 divided by 2, do you all agree that's the same thing as saying 8 divided by 2 plus 6 divided by 2? Yes or no?
Yes.
Yes. Okay. So negative 3y plus 8 divided by 2 is the same thing as saying negative 3y divided by 2 plus 8 divided by 2, which is 4. Now that kind of looks like something that you've had before, quite a bit of. Whenever x is by itself and use your t-table, you're going to pick numbers for which letter? No. X is by itself. You're going to pick numbers y. And if I'm going to choose particular numbers for y, I'm going to choose numbers for y that are divisible by 2, this denominator. What's an easy number to always use?
0.
0. So if y is 0, I get x equal negative 3 halves times 0 plus 4. Negative 3 halves times 0 is 0. 0 plus 4 is 4. So that's my x value, my x coordinate. So therefore I get the ordered pair 4, 0. What's another nice number to use for y? 2. So if y is 2, I get x equal negative 3 halves times 2 plus 4. Negative 3 halves times 2 plus 4. And then remember, the whole point of choosing a number that's divisible by 2 is so this denominator is what number?
1.
We want this denominator to be 1. Okay, so 2 divided by 2 is 1, 2 divided by 2 is 1. So this product I have circled is what product?
Negative 3.
Negative 3. And negative 3 plus 4 is 1. So that's my x coordinate. Okay? And then remember, I'm going to ask for 3 ordered pairs. So give me another number for y. Pick a negative one this time. Negative 4. That'll be fine because I think it'll fit in the plane. So negative 4. Negative 4. So when x is negative 4, I'm sorry, I didn't mean x, I meant y. When y is negative 4, I get x equal negative 3 halves times a negative 4 plus 4. And so 2 divided by 2 is 1. 2 divided by negative 4 is a negative 2. So what's this product right here?
6.
That's 6. 6 plus 4 is 10. So in your plane, in your coordinate plane, you're going to plot those 3 points. Now your test going to have some rulers. But so you're going to plot these 3 points. So this is 2x equal negative 3y plus 8. All right, and so when you do that, you're going to get, so it's 4, 0 is here. 1, 2 is here. 10, negative 4, 10, negative 4 is here. 1, 2, 3, 4. Say it again?
Use negative 4 for y? For the last one?
Yes. Yeah. I chose a number divisible by 2. Now you could have chosen any number divisible by 2. Negative 2, 6, negative 6, 8, negative 8, and so on. If you choose any other number, you're going to end up with a fraction. So it's usually easier to choose numbers in which these coordinates are integers. All right, now if it says label, make sure you label. So that means tell me what those ordered pairs are. So that's 10, negative 4, 4, 0, and then 1, 2. And so you just draw your line. Now, when you do this, again, on the test, because the test is going to be what's going to matter, extend your line through those points and you draw an arrow. All right, so that's this line. Okay? Then we looked at this real quick. Suppose you had 3x. Let's graph. 3x minus 6 equal, let's say, 3. Now, what kind of equation is this? It's linear. What letter is missing? Y. So whenever one of the variables is missing, you're either going to get what kind of line will you get? Either what?
Horizontal or vertical?
Very good. Very good. Horizontal, vertical. All right. And so in this case, if you're given this kind of equation, what might you want to do?
Theoretically, could you say y equals 3?
No.
So
No.
You would add 6.
You want to get x by itself. You want to get the variable by itself. Okay, so get the variable by itself. So first of all, you're going to add 6 to both sides. And so I get 3x equal 9, and then what?
Divide by 3.
Divide by 3. And now you're told that x equals what? 3. So then think about that t-table. What that means is that x is always going to equal what? 3. So in your t-table, remember we talked about this, x always equals 3. So along that column, you're going to have what? 3. Nothing else, because that's what this says. X has to be 3. It cannot be anything else. But y can be whatever you want it to be. So when x is 3, what do you want y to be? 2. If x is 3, what do you want y to be? 0. If x is 3, what do you want y to be?
Negative 4.
Negative 4. And so on. There are infinite points here. And then you plot those 3 points, and what kind of line do you get? Don't say straight. What kind of line do you get? Vertical. Vertical line. All right, so 3, 2 is here. 3, 0 is here. And then 3, negative 4. 3, negative 4 is here. And again, if it says label, this is what you do. You label these. And then you draw your line. And notice it is vertical. Okay? All right, so that was the equation 3x minus 6 equals 3. All right, so if you got y by itself, If all you had was the variable y, no x, what kind of equation would this be? What would the graph be? I'm sorry. Horizontal, vertical?
Horizontal.
Horizontal. Y equal a number would be horizontal. All right. Okay. Then we talked about this. Let's say, let's say 9. All right. So let's graph 2x minus 3y equal 9 using intercepts. All right, so that's on your test. And I think that worksheet is due Thursday. The worksheet on intercepts is due Thursday. So when it says using intercepts, how many points are you going to plot and label?
3.
2. You said 3 or 2?
I said 2.
2. Okay. Because you're going to plot the x-intercept, you're going to plot the what? Y-intercept, right? Okay. That's all it says. Use intercepts. There's going to be an x-intercept, there's going to be a y-intercept. So to find the x-intercept, and this is the way we did it, to find the x-intercept, you're going to let what? Not 0 equal x, because no matter where you are on the x-axis, what is the y-coordinate? 0. So if you want to find the x-intercept, you're going to let y equals 0. So if y is 0, where we see the variable y, you're going to plug in 0. So I get 2x minus 3 times 0 equal 9. So what's 3 times 0? So this part is just what? The left side. 2x. And then how do you get x by itself? Divide both sides by 2, and you found your x-intercept. The x-intercept is going to occur on the x-axis at 9/2 or 4.5. So as an ordered pair, though, I'm probably going to ask you to state as an ordered pair in the test. As an ordered pair, what are you going to write?
4.5.
4.5 or 9/2, doesn't matter. And then what? 0. Okay. To find the y-intercept, what do? You let x equal 0. So this time if x is 0, remember, see the variable x, you're going to plug in 0. I get 2 times 0 minus 3y equal 9. What's 2 times 0? Now what's 0 subtract 3y? A negative 3y. And that's equal 9. And then you just got to get y by itself. How do you get y by itself? Divide both sides by negative 3. And you found your y-intercept. The y-intercept is going to occur, the graph's going to cross the y-axis at what number? Negative 3. As an ordered pair, what is that? Make sure you put the correct coordinates. 0, negative 3. All right, and then you plot those 2 points, and there's your graph.
What is the instructions going to say on that one?
Graph using intercepts.
Is this the only time that we use this? Because I was getting real confused on the
Say it
homework.
again.
Is this the only time that we're going to use the zeros when you're using the intercept? I was just getting confused on the homework on when to use.
Well, I mean, when we did it at T-table, we used zeros as well. Right, but if you're going to find the intercept, the x-intercept is where y is 0, and the y-intercept is where x is 0, so you have to use zeros there. Okay.
The intercepts.
All right, 4.5 zeros here, right? Right in the middle of 4 and 5. Y'all agree? That's just right here. So there's your x-intercept. Your y-intercept is 0, negative 3. That's this. And then you just draw your line. And this is what you get. Okay? All right. All right, so again, you got to remember to find the x-intercept. You let y be 0, because no matter where you are, guys, look, no matter where I am on this x-intercept, what is the y-coordinate? No matter where you are on the x-axis, what is the y-coordinate? Zero. We talked about that several times. No matter where you are on the y-axis, which coordinate is 0? X. All right. Okay, so that was the graph. Which one was it? It was 2x minus 3y equal 9. Okay. All right. So you're going to have, again, you look at the study guide, you're going to have one or two where you're going to have to graph using intercepts. Okay, all of you turned in your worksheets to do today? Nothing else, right?
In my car, I thought they were in this folder, but I don't have them. I mean, they're outside.
Okay,
Maybe get them, or you want me to give them to you?
just quickly go after class and get them. All right. Okay, now, that was a quick review. We're going to continue on with the idea of slope. Now, towards 6 o'clock, I need to talk to you, not 6 o'clock, 7 o'clock. 7 o'clock, we need to do those word problems with inequality. So I gotta do that. That's from section 9.7. So we need to do some of those. It's real easy. It's not difficult. And all right, so let's look at this now.